All right, hello college algebra students. This is the first video of two that I'm doing in regards to four, which is solving 3x3 systems of equations. So what I'm going to do is I'm doing two examples related to the content in topic 4, which is learning how to do traditional elimination for any 3x3 system and Gaussian elimination for any 3x3 system. So the examples that I am doing will be the same for both traditional and Gaussian. So you can see both ways on how you solve it. This topic will be a very quick topic. You will not have an exam. Instead, you're going to be doing an in-class major grade activity related to this topic. So please watch this video, take notes, keep track of how I am doing the problems, and when I give you the assignment, please do the assignment. Practice this because the major grade activity that you will be doing later will result in you showing mastery on this topic. So, without further ado, let's get started. So I am showing you how to do traditional elimination. So this is for traditional elimination. And by its name, we're using elimination. So when you're solving a 2x2 system, you need to eliminate one variable and solve for the other. Because this is a 3x3, you need to eliminate two variables to solve for one of them, and then you'll work backwards. Okay, now how do you start? First off, you number each equation. So this is equation 1, this is equation 2, this is equation 3. And so now you're going to pick a variable to eliminate, whichever is easiest. Let me repeat that. You're going to pick a variable to eliminate, whichever is easiest. Okay? Now, looking at your variables, you have x, y, and z. I'm going to choose to eliminate x because I can set up the equations easiest by eliminating x. Now, in order to do this, I need to pick two equations. So I'm going to pick for my first go around, I'm going to pick equation 1 and equation 3. Because here I have negative 2x and here I have x. So all I have to do to eliminate x is to multiply this bottom equation by 2. So here we have negative 2x plus 3y plus 4z equals 1. And then for the second equation, I have x plus 2y plus 3z equals 5. So now, like I said, I'm going to multiply the second equation by 2. And so I rewrite it, and it is 2x plus 4y plus 6z equals 10. So notice that because of this multiplication, everything has been multiplied by 2. So now I have 2x plus 4y plus 6z equals 10. So as I said, we're going to eliminate x. So what I'm going to do is I'm actually going to erase this line here so that you can see what I'm doing. And now we're going to add each term from top down. So essentially we're just taking negative 2 and adding it to 2x. 3y added to 4y, 4z added to 6z, 1 added to 10. So this gives us, I'm going to write it over here on this left side here, okay? This cancels, and so I get 7y plus 10z equals 11. Okay, I'm going to denote this as equation 4 because this is going to be the next step in order to figuring out one of the variables. I used equations 1 and 3. I eliminated x, and now I have two unknowns. I don't know what y and I don't know what z is. Okay, so we're going to duplicate this That means I'm going to pick two different equations, but I'm going to eliminate the same variable. Once again, I'm going to pick two different equations, but I'm going to eliminate the same variable. So I'm going to erase this part so I have room. And now I'm going to pick equation 2 and equation 3. So now I have 3x and I just multiply the second equation by negative 3. Now I'm going to pick equation 2 and equation 3. So 3x minus 4y plus z equals negative 7. And then x plus 2y plus 3z equals 5. And I'm going to multiply both sides by negative 3 for the second equation. That's going to give me negative 3x minus 6y minus 9z equals negative 15. Okay, so again, I multiplied the second equation by negative 3. I just distributed negative 3 to each term. So now I'm going to erase this line. And now I will show the elimination. So the x's are gone. And then I'm adding top down. So negative 4 plus negative 6 is a negative 10y. Z minus 9z is negative 8z. And negative 7 plus negative 15 is negative 22. Okay, be very wary and careful of your negatives. And this I'm going to denote as equation 5. So I picked two equations, eliminated x, and got equation 4. I picked two different equations, eliminated x again, and got equation 5. So now, cleaning up this part so I can do the next step. Now I'm going to use equations 4 and 5, and now I'm going to eliminate one of the variables and solve for the other one. So I have the two equations I have here now I'm working with is 4 and 5. So I have 7y plus 10z equals 11, and negative 10y minus 8z equals negative 22. Once again, you want to pick the variable that's easiest to eliminate. Now, technically, it doesn't really matter which one you choose. You can eliminate y or z. I'm going to go ahead and eliminate y. So in order to eliminate y, I have to multiply both equations by the opposite coefficient. So what I mean by that is that in order for me to eliminate the y here, I must multiply by 10. And in order for me to eliminate the y here, I must multiply by 7. Because 70 is the common multiple. 7 times 10 will give me a positive 70, while negative 10 times 7 gives me negative 70. So rewriting this, I have 70y plus 100z equals 110. And then I have negative 70y minus 56z equals, and then negative 22 times 7 is, 7 times 2 is 14, carry 1 as negative 154. All right, so now we add top down. The y's are going to cancel. 100 minus 56 is 44, so 44z. And then 110 minus 154 is negative 44. Divide both sides by 44, and we get z is negative 1. Okay, so z is negative 1. Now that I have z, I can find y by going back to the original either equation 4 or equation 5. So we found z, so we can plug that into either equation 4 or equation 5 to find y. All right, so that's what I'm going to do. I'm going to plug it into equation 4 to find y. So 7y plus 10 times z, which is -1, equals 11. That gives me 7y minus 10 equals 11. Adding 10 to both sides gives me 7y equals 21. And then dividing both sides by 7, y is 3. So now I have y and z. So now I'm going to go back to one of the 3 original equations that I started out with. So either equation 1, equation 2, or equation 3. I'm going to plug in for y and z and solve for x. The easiest equation to use here is equation 3. So that's what we're going to do. So we're going to erase this part here to finish off this problem. So x plus 2 times y is 3 plus 3 times z is -1, and that's going to equal 5. So this gives me x plus 6 minus 3 equals 5. 6 minus 3 is a positive 3, so x plus 3 equals 5. And when we subtract 3 from both sides, we get x equals 2. So we have x, y, and z. Whenever you are writing a solution to a 3 by 3 system, you write it as an ordered pair. And since there were 3 unknowns, then we write our ordered pair with 3 variables, x, y, and z. So the answer to this question, or the solution to this system, and I will put it in black here at the top, is x is 2, y is 3, and z is -1. And there is the solution to this 3 by 3 system. So that means if I plug 2 for x, 3 for y, and -1 for z, it will be correct. I will get 1, -7, and 5 for all the answers. So plugging in 2 for x, 3 for y, -1 for z in the first equation will give me 1. Second equation will give me -7. Third equation will give me 5. So this is your goal, is to get the ordered pair or the solution to this 3 by 3 system. All right, so I'm going to do one more example in the traditional elimination aspect. And then in a separate video, I will do the same 2 examples, but show you how to do Gaussian elimination. So I'm going to clear all of this. And now I'm going to paste this second example. And so here is the second example. And so once again, we're going to label 1, 2, 3. Once again, pick the easiest variable to eliminate. Turns out, in this case, y is the easiest variable to eliminate because I can match up equations 1 and 2 and knock out y immediately. And then I just need to match up either 1 and 3 or 2 and 3, and I can easily eliminate from there. So for the first matching up, excuse me, the first matchup, I'm going to do 1 and 2. So that's going to give me x plus 3y plus 4z equals 14, and 2x minus 3y plus 2z equals 10. And since the y's are automatically going to eliminate, I just need to add top down. So the y's are gone. and I have 3x plus 6z equals 24, and this is my equation 4. So I will hold on to that. So that was me choosing equations 1 and 2. Now I'm going to choose equations 1 and 3. So doing this, I get x plus 3y plus 4z equals 14, and 3x minus y plus z equals 9. I just need to take the second equation here and multiply it by 3, because once I do, the y will become negative 3y, and I'll be able to eliminate the y. So here, when I multiply everything by 3, I get 9x minus 3y plus 3z equals 27. Okay. I'm going to erase the middle part here because I did the multiplication. And so now I'm going to add top down, and that gives me 10x, the y's cancel, plus 7z equals 41. And this is equation 5. So now I have equations 4 and 5. All right, so I'm actually going to rewrite them off to the side here. So this is 3x plus 6z equals 24. And then 10x plus 7z equals 41. Okay. So I'm going to erase, oops. Sorry, got too close there. I'm going to erase this so I have room. So equations 4 and 5 are there off to the side, and now I need to eliminate a variable, whichever is easiest. And in this case, I'm going to eliminate x. So once again, this is 4 and this is 5. So eliminating x, that means I need to, let me just rewrite the equation first. So 3x plus 6z equals 24, and 10x plus 7z equals 41. So I'm going to multiply this top equation by 10 and this bottom equation by negative 3. Because then I'm going to get 30x here and negative 30x here, and they will cancel. So rewriting each of these, I get 30x plus 60z equals 240. For the second one, I get negative 30x minus 21z equals, and then 41 times 3 is negative 123. So then adding top down, x's cancel. 60 minus 21 is 39, so that's 39z. And then 240 minus 123 is going to be 117. Dividing both sides by 39, z is 3. Because when you do 117 divided by 39, you will get 3. So we have z. So now we're going to go back to our equations here. So either equation 4 or equation 5. Now we need to figure out what x is. Because we found z, let's find x. Easiest equation to plug into, I'm going to choose equation 4. So 3x plus 6 times 3 equals 24. 6 times 3 is 18. So you have 3x plus 18 equals 24. Subtracting 18 from both sides gives us 3x equals 6. And that tells us that x is equal to 2. Once again, I have x and I have z. I have two of the three. I need to go back to the original equations that I started out with, and I need to plug it into one of the three original equations I'm going to solve for y. The easiest one to plug into, in my opinion, is the last one because y is it's just y. So we're going to do here, I'm going to plug in what I know, so that's 3 times x is 2 minus y plus z, which is 3, equals 9. 3 times 2 is 6, so 6 minus y plus 3 equals 9. 6 plus 3 is 9, so negative y plus 9 equals 9. Subtracting 9 from both sides gives me 0, so negative y equals 0, and then y is just 0. When I divide both sides by negative 1, y is still 0. So my solution is 2, 0, 3. If I plug in 2 for x, 0 for y, and 3 for z, it will give me 14, 10, and 9 respectively for each. So this is traditional elimination. Pick two equations, eliminate a variable. Pick two different equations, eliminate the same variable. Then you'll go from a 3 by 3 to a 2 by 2. Solve the 2 by 2, eliminate one variable, solve for the other, and then you just backtrack. So you work your way back up. So you have one of the variables, you go back to your 2 by 2, find the other variable, and then once you have those two variables, go back to your original 3 by 3, pick one of the three equations, and solve for the missing variable. All right, so this ends the video notes on traditional elimination. The next video will do the same exact examples, but we'll introduce you to Gaussian elimination. All right, so until we meet next time.